everyone, Miss Aguilar here. I'm just going over the notes that we went over a few weeks ago for anybody who needs some extra help. Um, the reason why I did this is because I wanted to show you guys or help you compare the two labs. The first lab was the buggy lab, and we were talking about constant velocity for this unit. The second one was the inclined plane lab, and we're talking about changing velocity or acceleration for this lab. And I wanted just to see or be able to compare how a position time graph of a constant velocity and a position time graph for a changing velocity, what they look like and how you can tell the difference. So for the buggy lab, we see a line on our position time graph that has a constant change in its position. And what that means is that it is changing its position at the same rate. If we were to say it was moving along and for every second that passed it, increased its position by 2 meters, then we would say that its velocity was a constant 2 meters per second. Now, for our inclined plane lab, it actually has a velocity that is changing. It actually has a velocity that starts off slow, right? So maybe you increase your position by 1 meter and then by another 1 meter. And then somewhere along the line here, it starts to get faster and faster. So instead of moving 1 meter every second, you're now moving like 3 meters per second. And then here it gets even faster, so maybe you're moving at like 5 meters per second. And here maybe you've changed your position by 6 meters every second. And then here maybe it's like, 8 meters for every second. It's just that it's increasing. And that translates into your velocity. So your line represents whatever the graph it's on. Whatever graph the line is on, the line itself, not the slope, represents whatever graph it's on. So for example, this line is on a position time graph. So this line represents the position of our buggy at every second. This line is doing the same thing, except it was on the inclined plane lab. So it represents that wheel and axle that you guys let roll down the two metal pipes. It's representing the position at every second. Now, the slopes of these lines, so what I mean by slope is if we calculated, 2 points along the line. So if I calculated this point and this point, I'm able to calculate what the slope was. What that means is the change in, okay? And the slope of this line represents velocity as well. So position time graph, the slopes of those lines represents velocity. Moving down into the velocity time graphs, it's the same thing. The line itself represents whatever kind of graph it's on. So this line here represents the velocity at each second. And the same with this line. It represents the velocity at every second. The slope of this line represents something else. It represents acceleration. And we'll move on in the next couple of pages and discuss that a little bit further. So here we have a constant slope, which is a constant velocity. And a constant velocity here is shown with this horizontal line. Constant means not changing, means maintaining, moving at a steady velocity. So at every second, if we were to sort of mark here and here, we could see that every second that passes, our velocity is exactly the same. Every second. All right, that's what that shows. Here, it's a little bit different. At every second, our velocity is actually going up and up and up and up. So to start, right, our initial velocity at 0 seconds is actually 0 meters per second. We're not moving at first. And then as time passes, we get faster and faster and faster. All right, the mathematical models for these graphs were just a little bit different. We were able to follow the y equals mx plus b for any linear graph, which is this one here, our position time graph on our buggy lab, and our velocity time graph on our inclined plane lab, because they're both linear. See that? All right, but when we were doing the mathematical model for our position time graph on our inclined plane lab, it was just a little bit different because we have a curved graph here. So we couldn't use exactly y equals mx plus b. We actually had to tweak it a little. And what I mean by that is we had to change our t to t squared. So for our position time graph on a changing velocity or a curved graph, a curved line on a position time graph, we ended up with, the format was, let me write it here. The format was y equals mx squared plus b. So this squared part is different than the y equals mx plus b. This one we can use on a linear graph. This one we use on a curved graph. And as you can see, our x variable was time, so we squared our time. Now, at the beginning of all of this, I didn't tell you guys what the m was, but I told you all yesterday, and it ends up to be 1/2 acceleration. So we all know that now, and so there's no use in hiding it or not telling you. So now you know. So these are the two mathematical models for the two labs. We have this one here for our buggy lab and these two for our inclined plane lab. Now you're probably wondering, why don't we have a mathematical model for this one? And that's just because it would end up being 0, and we know our velocity already here. Okay? All right. Let's move on. So now I'm going to show you guys the difference between increasing and decreasing slopes. So let's start off with talking about a slope that is increasing. And we just saw that in the last page. So an increasing slope looks like that. Now, how do I know it's increasing? Because the best thing to do when you see a curved line on a position time graph is to make these tangent lines. Tangent lines are just lines that are parallel to your original line. And it helps you to see if your slope or if your line is getting steeper and steeper. Or we might call this more vertical and this, well, this is horizontal and this is vertical. This is getting vertical, getting vertical, getting vertical, pretty vertical here, and getting vertical here. Now, if your line is vertical, so if it looks like this, that means you have a great velocity. And maybe I shouldn't use the word great. Let's use the word faster or fast or faster. If your line looks like, here, let's put it over here. If it looks like that, that means it's going slower. All right, so slower here, faster there. So it's getting faster and faster and faster and faster. Now this is just not that line or that line. It's, I mean, look at these ones in between, right? It's getting more and more faster. So it's increasing. Sorry, no, that just sounded totally ignorant. More and more faster. But I hope you guys know what I mean. Anyways, let's talk about what the slope of this line represents. Well, what kind of slope is this? It is a changing slope, and it is a positive slope because it's moving from a position of 0 away from the origin to a positive position. So we can say that we have a positive changing slope. And what does that translate into? Well, the slope of a position time graph is velocity. So we have a positive changing velocity. I swear that's an O, not a B. But what can we say about how it's changing? Remember, it's either increasing or decreasing. And what did we just establish? We said that it is getting faster and faster and faster, so it's increasing its slope or its velocity. So we have a positive increasing velocity. Sorry, I just got a new stylus and I'm trying to do the best I can. It's not that neat. So how do I show that? Well, positive means that our line is going to be above this 0 line here on our velocity time graph. And changing or increasing means it's going to start off at a 0 velocity and increase to a greater velocity. And that's what this line here shows us. All right, but let's talk about the slope of this line, of this velocity time graph. The slope of that line is positive, and it is constant. We have a positive, constant slope. Now remember, the slope of the line and the line itself, they're different. This line shows an increasing y variable, which just happens to be velocity in this case. But the slope, remember the change in, right? The slope shows constant. So every second, it's changing or increasing by the same amount. So we have a constant slope. Now, what does the slope on a velocity time graph represent? Well, the slope on a velocity time graph represents acceleration. So we can change this word slope to positive constant acceleration. How do we show a positive constant acceleration on an acceleration time graph? Well, positive means that our line is going to go above the 0 line, or our x-axis, right? And it's going to be constant. That means that every second that passes, our acceleration will remain the same, will be exactly the same every second. So we're showing this horizontal line. This horizontal line means that we have a constant y variable, whatever your y variable is, okay? So we have a constant acceleration. This line means that we have a changing whatever the y variable is. So here we have a changing velocity. Okay, let's talk real quick about the signs between your velocity and acceleration. So here we have a positive velocity, and here we have a positive acceleration. So if you guys remember, I was saying same, right? Same signs on your velocity and acceleration means speeding up. So your object, whatever it may be, is actually speeding up. Okay, I'm actually going to end our video there. I'm at about 11 minutes or so. I'm going to do the motion map in the next video. So there's going to be probably about 3 videos for this one handout that you guys had. Remember, if you have questions, email me, and I hope this helps you guys. All right, until the next video.